Hi guys, and welcome to the Integrals Agentic AI tutorials. Today we will learn the most basic foundational thing. What are large language models or LLMs? They are the key part of any AI agent that we're going to be building. So it is important for us to understand, at least to a certain extent, how they work, what are their limitations, and what are their strong sides. So with that, let's begin. So what are LLMs or large language models? Large language models are a kind of ANN or artificial neural network. You're probably familiar with artificial neural networks. This is a mathematical construct that allows us to mimic the behavior of human brain, at least to a certain extent. And for instance, you're using artificial neural networks for image recognition in your self-driving car or in your pilot assistant in the car. So LLM is also a type of ANN. And they are built specifically to try to understand the human language. How do they do that? They are trained on the vast amount of data. So usually they're trained on all of the open internet and whatever data the vendors that train them, such as OpenAI, Anthropic, Google, Meta with Llama, etc., can get their hands on. Because the more data, the better quality of that data, the better LLM you're going to get. After this training, on top of it, they also undergo another loop of training called human feedback fine-tuning. And this is done to make sure they behave well in the chat format. So basically they're given several examples, or several hundreds of thousands examples of dialogues that are written by humans so that they learn how to actually talk to a human in the dialogue. Not just predict the next token, but also to mimic the behavior of question and answer format. So what is a token, you may ask? Token is actually either a small word or a part of a bigger word. For instance, if we take a look at the previous sentence and split it into tokens, you will see that most of the words are one token, but then the word probabilities is split into two, prob and abilities. And this is done because we found that by such a splitting, the LLMs learn the sense or meaning of what we're trying to convey better. For instance, because prob and abilities are separate tokens, they're able to construct new words from tokens or understand grammatical errors or understand new words, etc., etc. So this is just a smart way for us to optimize how they learn the representation of the language. But besides that, there is no magic, there is nobody sitting inside, there is no hidden reasoning. It's just prediction of probabilities of the next token in the context of the given tokens. That's it. That's how LLMs operate. So how are they able to help us? How are they doing all this seeming magic with solving problems or writing nice text, etc., etc.? Let's take a look at that. So let's try to understand a little bit the internal machinery of LLMs. How are they able to solve not just the problems that they have seen the solutions to, but problems that are analogous to those? An example. You have probably seen this typical Google or Microsoft interview question. How many tennis balls fits into a Boeing airplane? And if you ask any LLM this question, they would reason with you. They would try to estimate the volume of the plane, try to estimate the volume of the tennis ball, and make some basic calculations. Why? Because they have seen the solution to this problem many, many times in their training data. But then, if you ask an LLM a question, how many children's toys fits into a Tesla car? They would still reason with you in a very similar fashion, even though they have probably never seen a question formulated like that. And this gives us the impression of them able to reason. But Actually, what is happening is that they have learned lots of different reasoning chains based on the problems that they have seen previously, and now they're trying to apply analogies. How are they able to do it? Well, it turns out that we are representing words or the whole sentences as mathematical vectors. That's how it works under the hood. And you have probably seen this equation that I have here on the screen, that queen equals king minus man plus woman. And this is really an amazing equation, because basically what's happening here is that if you represent queen and king and man and woman as mathematical vectors using the special procedure that we use when we train LLMs, this is exactly the equation that we get. So if we use the vector math that you're probably familiar from high school, and you apply just the same rules, even though the vectors that we learned at school are usually two-dimensional or three-dimensional, and here this vectors are many more dimensions, but the same mathematical rules apply. So if you do king minus man plus woman, you would get a queen. This means that you can actually operate mathematically with those vectors. And not just that, but it turns out that in this multidimensional space, similar words or similar concepts are close with each other. So a plane will be somewhere close with a car or Tesla car. And this is why when an LLM sees a question, how many children toys would fit into a Tesla car, it is able to substitute a Boeing plane, which they have seen many times while training, for a Tesla car, and then a tennis ball, which is an object, a small object, and it would be somewhere pretty close in this multidimensional space to a children's toy, so it will substitute. In this way, they're able to reason about tasks that they haven't really seen, but for tasks that they have seen certain analogies, such as this example with the Boeing. So basically, it's important to know that we are able to represent the meaning or senses of the words or paragraphs of text as vectors, and then they're grouped by closeness in this meaning, and this way LLMs are able to not just repeat the reasoning chains that they have seen, but also apply them to certain new concepts. And this is what gives LLMs their power. But what about the limitations? So what is the main problem with LLMs, apart from the fact that they don't really reason? They sort of reason by repeating the reasoning chains they have seen previously and applying vectorized analogies we just talked about, but nothing more than that. The key biggest issue with any LLM is that they what is called hallucinate. If you ask a question, due to the architecture, they must provide an answer. There is no way. They will just generate those tokens. You give some tokens as input, they have to give some tokens as output. That's it. This means that if you ask them something, they will always provide an answer. Like if we ask an LLM who is Anton Antich, they will start coming up with some crazy ideas, such as Anton Antich was a famous Russian guitar player who lived 2 centuries ago, or something similar. Why? Because I'm not a famous person. They were not trained on the data about me. So they still have to provide an answer. So they come up with certain tokens that kind of make sense in the probabilities that they learned. And this is called that they hallucinate, which means you cannot trust anything you ask of ChatGPT. I always hear people, I asked ChatGPT this or that, and it told me this or that. Guys, you are being deceived, because if you are an expert, you are able to understand if they hallucinate or they provide a true answer. But then you don't really need to ask a question. If you are not an expert, you have no idea if they're lying to you. They will always tell you something, and they will tell you something very convincingly. So this creates a huge problem. How do we solve it? Well, luckily, there is a very easy way out, which allows us to make sure we can create AI agents that are useful and trustworthy. But key takeaway, do not trust anything you hear from ChatGPT or similar chatbots on the internet. You have to know what the source data is from which they take their answers. How do we do that? There is a way. So what is this way to ensure that they give us the answers we're looking for that are trustworthy? There is a very simple solution called context. They have been trained, as I mentioned, on vast amount of data that is available on public internet. And the more often they have seen certain piece of data, the more likely they are produce the correct answer about that. So they will normally give you good answers about things like Paris or Microsoft because they are very famous, but they will not give you good answers about Anton Antic, which is myself, or some other obscure companies or concepts. So how do we remedy that? We remedy that by putting the relevant correct information into their context, which is right here on the picture in green. How do we do that? It's very easy. Actually, every chatbot, the way they work, there is again no magic in them remembering the conversations or whatever. It's just with every call to an LLM, when you type something into a box, they send all the previous chat messages and they put it into context. And this way, they use the previous conversation history as constant context when generating the answers. So the same thing if we want to get some good, correct answers. We need to make sure there is relevant, good documents in the context that are relevant to the question that I'm asking. And then they will give us a very nice formulated or reformulated answer based on those documents. They're very good at summarizing the text, at finding the certain information in the text. So basically, the better information you have in the context, the better answers you will get. And they will always treat the context with higher priority than whatever they have learned, which means there is a very, very, very low probability they will hallucinate with a good, relevant information in their context. And this is what is called RAG, or Retrieval Augmented Generation. So let's take a look at it and finish this introductory video on that. So the final and very important piece of the puzzle on how to use LLMs correctly is RAG, Retrieval Augmented Generation. As we already discussed, they will not lie to you, they will not hallucinate if you put relevant, good information into context. And that's what RAG is all about. Normally, there are several different ways to do RAG. The most popular or the easiest one is via web search. Before asking LLM to provide an answer to a question, you do a web search based on your input. You put some documents into context, and then it will provide an answer based on those documents. This is an okay method because Google search is not always good. It does not always provide the correct data. There are various limitations to it. So the better way is to do so-called vector memory. We already discussed how words and paragraphs and any text in general can be represented as vectors. So if you put your corporate or your personal information that you trust into something that's called a vector database, then with each interaction, you do a search in this vector memory, you find relevant documents that you know you trust because these are the documents you put there. They become part of the context, and then an LLM will give you a reliable, trustworthy answer. So once again, very easy way to remedy the hallucination issue with LLMs is by using Retrieval Augmented Generation. And the best way to do it is using vector memory. So now that we have learned the basics, we can switch to integral platform and start building agents, applying everything that we have learned. We have learned what LLMs are, how they operate under the hood, how they're able to reason using vectorized representations, why and how they hallucinate, and how we can solve this problem using RAG. Thank you and see you next time.